Welcome back, everybody. Today's lesson, we're going to learn about the tides and what causes the tides and some other fun information here. Perhaps you've actually experienced the tides at the ocean. This shot you're looking at right here is the Bay of Fundy. This is in Canada. And what's really spectacular about the Bay of Fundy, you got to go there someday, is the tidal range, the amazing difference between high and low tide. And you can see here during low tide, those boats are stranded. They have to wait. They can't go anywhere until the tide comes in. But it does so quite regularly, as you'll find out. So when we think of the tides, at least for the oceans, there's other tides too, we think of the cyclic rise and fall of Earth's oceans due to the moon's and partially the sun's gravitational pull as well. You can see in the shot down there, high tide versus low tide. Now on the Atlantic coast, which is what we're concerned with mostly in this class, we experience a high tide about every 12 hours, 25 minutes from the last. And the same is true of low tides. Now if you wanted to go from a specific high to the next low, then you have to cut that 12:25 in half. So there's about 6 hours and 12 minutes, maybe 30 seconds or so between a high and the next low. Now this is not true everywhere on the planet. It's more complicated going to other places. Some places there's very little tidal range at all. But at least for us on the East Coast here, this is what we see. All right, now this diagram, first of all, you have to realize that the size of the bulges is way exaggerated. And the moon is much, much, much farther away. But what we can see is that when the moon pulls on the Earth's oceans and the Earth itself too, that's the tidal force. And gravity and inertia act in opposition on the Earth's oceans. This creates tidal bulges on opposite sides of the planet. So on the near side, the side kind of, you can picture it underneath the moon or the same side as the moon, the gravitational force of the moon pulls the ocean waters towards it. So there's a slight pull to the right here, and that creates a bulge on this near side. Now on the far side of the Earth, the force of the moon's gravity is not nearly as strong pulling to the right, not nearly as strong. So in essence, the inertia force is dominant, and that creates, the overall effect is a bulge outwards on the left side as well. So you have a bulge on the right and a bulge on the left in line with the Moon-Earth orbiting system. You also have to remember that the center of mass of the Earth and the Moon is somewhere about there, which means they kind of orbit each other in a sense. And this little diagram down here kind of shows a force kind of resolution of forces showing the tidal forces moving outwards at the left and the right hand side in line with the moon's orbit. There's very little tidal forces generated at the north and south pole. Interesting observations. Well, what we see here, this is a graph over 1 month, days here on the x-axis, and height of water in feet in New York City. And also placed on here is the phases of the moon. We have new moon, first quarter, full moon, third quarter, and new moon. Back to new moon again. And some interesting observations you can make here. First of all, if you look at new moon and full moon, you'll see that there's a slightly larger range from low to high. Low to high, low to high, than there is when you're at third quarter and first quarter. So at third quarter and first quarter, you can see the ranges, the differences between low and high are not as great. And we're going to get to why that occurs in a minute. But just take away the fact that during like new moon, and especially full moon, there's a really big range between high and low tides. And between the quarters, first quarter, third quarter, is the least range. Okay, and there's something going on there that's causing that, which we'll get to. Now, there's names for this. Spring tides, neap tides, spring tides, and neap tides. And these actually occur twice per month. Each one occurs twice per month. And as you can see in the first picture, the moon, now none of this is drawn to scale obviously, but the moon is directly in line with the sun and the earth. And because of that, the sun's gravity, which is pulling on the oceans as well, kind of adds up with the moon's, and we get a slightly larger tidal bulge during new moon. Now the same thing occurs during full moon, when we're also lined up. And the opposite occurs at first quarter and third quarter moon, because the moon, earth, sun system are at right angles to each other, 90-degree angles. And that tends to negate the gravitational forces somewhat. And so you'll notice that the tidal bulges are not as extreme. And that's what we saw in that New York City graph during first and third quarters. Not as extreme. But at new moon and full moon, we have a much larger bulge. And that's because the gravitational attraction of both the sun and the moon are in alignment. And so these two diagrams show that quite well. Let's take a look at that. See if this thing's working. It's kind of nice here. You can see the moon orbiting the Earth once a month, and the Earth's also rotating pretty fast too, but not as fast as it should in a real situation. Moving on. So this is showing how the moon's gravitational attraction creates the tidal bulge on the moon side, and then the corresponding opposite side of the Earth's high tide or bulge due to the inertial force being stronger than the moon's gravitational force acting on that far side of the Earth. And the sun, as we talked about before, also exerts a gravitational force. And as you can see, it's highest when the moon and the sun are in alignment with the Earth. And it's the least effect when the Earth, moon, and sun are at right angles. So just remember, the phases of the moon where spring tides occur and where neap tides occur is a question you'll probably be asked. At least with me you will be. And so you have to know the new moon, full moon is for the spring tides, and the first and third quarters are for the neap tides. And that's what this says here. Just a quick review. The term tidal range, make sure you know, is like the difference between the lowest and highest tide, and that's the tidal range. And you can see it in this little applet on the right. Low tide is at the bottom there, high tide right about now, and the difference is just simply the tidal range. And spring tides have the greatest tidal range, and neap tides have the least tidal range. Now this last slide here, this is not a real photograph. This has been photoshopped. Tidal waves, which is what a lot of people, including folks in the media, use the term wrongly in the place of tsunamis. These are created by changing tides and are usually harmless. So that's not real. Tidal bores is another term for tidal waves. It's usually the term we use. And it occurs when these tidal waves move up the mouths of rivers. And you know, it's kind of cool to watch. You can actually see you know, kayakers surfing the wave as it moves up. And so just don't confuse the two terms. A tsunami is the term that often is the term should be used on the news, and they incorrectly use tidal waves. All right, so hopefully you'll learn a little bit about the tides. See ya for the last video coming up next.